Hey, today I want to talk a little bit about Windows. I got really fascinated with how to make Windows recently because Windows are kind of interesting. It's old technology, but it's really expensive to buy custom Windows these days. And a lot of it is aluminum. If you want wood windows, they could be 800, $1,000 more, depending on the size and so on. So the book that I kind of referenced is this little guy I saw on a Lost Art Press. It's a great little book with an interesting history. There's an excerpt available here. And apparently, it was kind of written back in around the late 1800s and used in the early 1910s, turn of the century. And it was literally found by a guy at the bottom of a chest of tools, that his father gave to him and his grandfather gave to his father, and so on. And there's really great little drawings in here, dimensioned, and which explain kind of how traditionally doors and windows were made out of solid stock wood, hardwood, softwood, but solid wood. Now, it's not really difficult or complicated technology, really. It's fairly straightforward. But there are some little wrinkles and things like that are important that I kind of read about in the book, and I wanted to replicate. So I built my first one out of wood using the directions given in the book. But then I thought, okay, I got a CNC machine, so I really wanted to test how I could kind of marry the traditional methods with a CNC digital fabrication technique. So that's when I started to design my own casement windows. Now, I've 3D modeled my opening in my house, um, and that with the window and everything looks approximately like this. So let's just hide some stuff and let's go over the rough opening. Um, it If you checked out my other video, there is some information about how to remove an existing vinyl window, which were commonly installed in old houses, and also how to prep your opening to accept a new window. So take a look at that. But here is the rough opening, okay, with the window out of the way. Let's turn on a section so that we can take a look more at this in detail. All right, so here is a section of my rough opening. Um, and what's really nice about these old houses is that I have a solid wood sill made out of old growth wood. It's a really nice uh, part of the house. But as I mentioned in my previous video on the vinyl windows, what traditionally was done was that these vinyl windows were caulked at the outer face and then just kind of slapped on up against wood stops. So here's a wood stop. It's like just a pine piece of wood, and the window was just slapped on here. There's also one on the side, which I've removed from the 3D model because I took it out from my rough opening, and there's also one at the bottom of this on the sill. So as you can imagine, if water gets back in there, which it inevitably does, right? So the stops not only stop the window, but they also stop the water from escaping. And so the water would sit on the sill and essentially start to rot away the wood. So the first thing I did was to remove all those and to kind of reprep and get that sill ready to accept a new window. Now, this little area that's empty right here used to be where the interior kind of finished wood sill is. I think I took it out and I'm going to replace it with a new one. So I'll show that in a little bit. All right, let's take a look at the frame of the window. Okay. This is that new sill that I was talking about. Okay. Let's go ahead and hide that so it's out of the way so that we can see only the frame. The frame essentially sits in the rough opening. There's a gap here, so I shimmed that later on with some custom shims that I 3D print using this exact slope of this pitch here to fit that in. This is going all the way to the top. Now, the material that I used to make my new frames out of is this marine grade plywood. Okay, it's really nice material. It's called Hydrotech, and it's 18 millimeters, roughly 3/4, but it's exactly 18 millimeters. It's a multiply, so it's got 13 of these layers. It's really heavy, but it's solid wood. It's not solid, but it's really sturdy, and it has a really nice finish. I really like the finish. It's not the kind of rough marine grade plywood that you may have seen in big box stores. This is made in conjunction in accordance with the British Standard 1088, which, as far as I can tell, is just kind of a requirement on the glue and on the manufacturing quality of the marine grade plywood, and it's obviously used in boat purposes, in boat applications. It also comes in a 12 millimeter, approximately half inch size. So going back to my frame, what you can see is that it's mostly composed of 4 pieces: a head, 2 jambs, and a sill. Okay, and it also has this cross member here as well. And this top section is to accept a fixed piece of glass, because the original opening was for a double hung window. So in that dimension, it has 2 sashes, 2 little windows, right? If I were to make this whole thing a casement window, it would effectively be around 5 feet tall, this vertical dimension, and 3 feet wide is my rough opening. That's kind of a little bit too big for a casement window. I think that's a little unwieldy. So what I've done was essentially knock off a foot off the top for a fixed piece of glass, which makes the frame a little bit more complicated, but yeah, it is what it is. Traditionally, these window frames were thicker, but I'm kind of testing this 3/4 material that has an additional edge of half-inch material. So altogether, a little bit over 2 inches, but not the entire dimension. And also, traditionally, the wood frames were made with mortise and tenon joinery, which I think, obviously I would prefer that, but given the digital fabrication techniques, I would use a rebate here, or a rabbet, whatever you want to say, a dado here, and similarly at the bottom, another rebate. Oops, sorry about that. Right there. It's just easier for me to fabricate. Okay, going back to the head, and taking a look at the section here. This is that main 3/4 piece at the head, and this is that half-inch thickness. And what you'll see is that I've cut a curve into this so that this becomes a drip edge, such that if any water kind of flows down and over, that there's a lip for it to drip off of. At this intermediate sill, I also have a channel built on to the top of that sill. Again, that can collect any water that seeps back there. And these little channels are sloped, okay, moderately, so that they can purge that water out, these little weep holes. At the bottom, similarly to the top, there's another little drip edge, again, for water to drip off of. And on the interior, what you see is this little pocket here. That curved pocket is to accept a weather gasket seal. Now that pocket runs all the way to the top and then down the sides. Now at the bottom, similarly again, I have a weep channel and these little holes that will allow any water that gets back there to drain out onto this sloped sill and exit the building. All right, let me turn off the frame so that we can, sorry, the rough opening. So this way we can just sort of understand the frame itself and then how the sash sits into the frame. Here is the sash. Okay, again, the top portion is empty because it's going to accept one fixed piece of glass. The sash is made out of two pieces of that 3/4 18 millimeter material laminated to each other. Okay. The top dimension is approximately 2 inches because I'm working in millimeters now, so sometimes it's off numbers. The side is approximately 2 inches. Again, top and bottom, top and jambs are the same, and then the bottom piece is thicker. It is approximately 3.5, exactly 3.5. These two pieces are glued and laminated together, and I use these little 3/8 dowel pins in order for me to align the pieces together more easily. And I have a 3/8 gap all the way around the sash and the frame so that they don't bind against each other. And on the hinge side, which is not this side, but the other side, well, it could be either side, but in this model, it's on the right side. This side is chamfered, or you can radius it so that it doesn't catch against the frame. The outer half of the sash has a rebate built in to accept the glass. And this pocket down here is meant to hold the friction casement hinge. Let me pull out the section a little bit so that we can see the hinge better. Okay. That's good. Let's zoom back in. And I'll turn on the hinge. There it is. Okay. This hinge, okay, I can isolate that and see. And I'll turn the turn this section off. Here's the hinge in its entirety. And there's two of them. They come in a pair, in a top and a bottom. And the one I am using is 16 inches long in this direction. Okay. This one is the CRL 4-bar heavy duty hinge. It's 16 inches in length and it's rated up to 67 pounds. Now there's a standard duty one, which only works for sashes up to 40 pounds. My sash weighed everything together is 42 pounds. So I jumped up to the next level. There's also a even heavier duty, extra heavy duty one that is rated for like sashes that are over 100 pounds. But those hinges are real expensive. So like $40, $50 or so for each. So you're looking at $80 right there for a pair. Move my section back in so that we can talk a little bit more about this. So that pocket is where the hinge sits right there. Okay. When you're installing this hinge, it needs to be flush up against this outer face. Oh, and one thing that I forgot to mention is that my sashes are meant to open to the inside of the room, actually. Why? Because they're actually really hard to find. It's hard to find a inward opening casement window here in the States. They're a lot more common in Europe. I think it's nice because you can open it to the inside, and I'm usually not opening my window like all the way out. If you do that, yes, the window is going to be in the way in the room, right? But I don't usually do that. I open it for ventilation purposes, but it can open pretty far. This one is, I think, opening to 55 degrees, a hinge. But I think if you open it in, you can also clean the window glass on the outside much more easily. And for installation purposes, if you open the hinge in, that means you can hold the entire sash more carefully, more sturdily, as you install them in the rough opening. Whereas if they open out, you kind of you either have to fit it onto the whole frame and install the frame, or you if you install the sash second later, you have to dangle this thing out of the window, which is a little precarious. All right, so in terms of the glass, here is the sash, the IGU, the insulated glazing unit that sits in the sash, okay, up against the rebate. Now there's a little gap here, right there. That's 16th inch, okay, 1/16 of an inch, and that's meant to accommodate the glazing tape, which is a double-sided tape that seals the glass against the sash and seals out the weather. So that is also up here as well on this gap. There's a gap at the top and the bottom as well, okay, and that is meant to accept a setting block like so. These are kind of like neoprene or rubber blocks that set the glass off of the wood. Traditionally, solid wood windows are going to contract. That's why you need that gap, right? You need that spacing. But actually, with my plywood construction, the plywood is very dimensionally stable. So I think there's less need for that. But I think it's still very good to maintain that spacing. So in terms of the glass, mine is a half-inch thick, double-sided insulated glazing unit with a low E coating. The low E coating I use is Solar Band 60. So around here, you can get Solar Band 60, Solar Band 70, and so on. And other places, you might want to even go with triple pane glass, but that's a much heavier sash. I'm going with this double pane glass. You can't order it from the IGU fabricator directly. You need some kind of like special glazing license, which I don't have. So I order it from just local shops like Ace Glass around here in the San Francisco area. And what I order is a narrow sightline, which is meant to be recessed in this kind of half-inch rebate, such that this is about half inch, right? And similarly, this is about half inch. So all of the components, the metal that goes into forming the IGU unit, um, are slightly narrower so that they fit within this half-inch stop. I think the narrow sightlines are 3/8 of an inch. This way that all you see is glass theoretically if you do it well. Okay, so next component that I can share is the seals. Okay, I have two seals. I'll turn on the frame. I guess I can turn on um, the seals so that you can see them. This is the gasket that goes up against the frame on the outside. Okay, there's a stop right there, which I had hidden. This hit stop has a similar kerf that is cut into it. And so this gasket goes all the way around the bottom, okay? And then it goes up the sides, jams. And then at the top, there's also this stop, which we talked about earlier, and has that curve built in. So this gasket is, let's see, which one is this? This one is, I believe, the AM 12364. I selected this profile. Let's see, I think I have this one. AM weather guard. This profile, I think, works pretty well to seal the sash up against the frame. There's a recommended amount of compression. I find that 25% works pretty good. I have a second set of set of gaskets. And they go, let's see, how should I show this a little bit more easily? They go here. Okay, so this gasket, I'll hide that, goes around the sides of the sash itself. So it protects against any additional infiltration. It's a secondary line of seals. So there, for these, I cut a similar kerf. It's like a 2 millimeter wide kerf that you use a router bit for, and then you sit the gasket in there like so. So this part number is AM 12032. I believe it is this one. It's more of like a round profile, so that seals up the little gap, the 3/8 gap between the sash and the frame. And that is about it. So I'll show you the CNCing of this frame and the sash in a separate video along with its assembly, and then finally the installation into the opening. Thanks for watching.